Hey everyone, continuing our reflections, we're looking at the reflections when we apply the negative sign to y. So we now have g minus y, h, x. And really it's the same way of thinking, right? If you ever have, let's say, positive values of y, then your now minus y will be negative. If you had negative values of y, you will now have positive value. So one way to look at it, another way to look at it is that you know that your positive values are all in the first and second quadrant. They now be at the third and fourth quadrant, and as such it's a reflection about the x-axis. Similarly, if your y value is negative, it will be in the third and fourth quadrant, and now it'll become positive, right? It's because it's in the case 2, and now it will just be in the first and second quadrant. Again, a reflection about the x-axis, right? And you can even use actual points, right? So let's say we again use the classic point of 1, 3, or rather 3, 1. Then when we reflect the graph about the x-axis, or we get g minus y, we know that y was originally 1, now we have minus y equals to 1, now we have y equals to minus 1, therefore we now have g comma minus 1. So again, graphically it look like this. This is 3, 1, and this would be the reflected point, 3 comma minus 1. The x coordinate remains the same, but the y coordinate becomes positive to negative, and again vice versa. If you have a negative y value, it becomes positive. As such, it is simply a reflection about the x-axis for g, y to g minus y. Of course, we also look at the more common case where, let's say, if you have y equals to fx, then now if you have y equals to transforming to y equals minus fx, then obviously it's the same idea. Fx is your value of y, now you get a negative of it, which means the same thing. Positive becomes negative y becomes positive y. Alright, so yeah, this is pretty much it for our reflections, and the next video we'll be looking at the combination of both scaling, translating, and reflecting.